Okay, next example, again, getting your list. Okay, so P, remember you go to your constant term, which in this case just happens to be a 1. So your only factors would be positive and negative 1. Okay, Q is your leading coefficient, which is the 2. So factors of 2 would be plus minus 1 and plus minus 2. Okay, so P over Q. So P's go on the top, so you'd put the 1 over the 1, and then you'd put the 1 over the 2. So 1 over 1 is just 1. Then when you put 1 over 2, then that'll give you a half, okay? So these are the only ones that you have to plug into the polynomial, and you need to find out of this list which one, and it could be more than one, but you need to find just one that will cause it to equal 0. All right, so you'd probably try the 1 first. So if you substituted positive 1 into this polynomial, you're actually going to get 4. So that's not going to be the one that you're going to want. Remember, you want the one that's going to cause it to equal 0. All right, so next on the list, you would probably try the negative 1, and actually the negative 1 would give you the 0, okay? So you've got to do the synthetic division with the negative 1. Okay, so I have a 2, and then I have an understood 1 here. Now I would have to put a 0 next, because what's supposed to come after your second power, remember, is an x to the first power. And since you don't have that, you've got to put a 0 in that spot, okay? And then now you've got your constant term of positive 1. Okay, so going through the synthetic division, bring your 2 down. So negative 1 times 2 is negative 2. Add, you get negative 1. Negative 1 times negative 1 is positive 1. Add, you get 1. Negative 1 times 1 is negative 1. Add, see, there's your remainder of 0, okay? So now you're going to take what you have across the bottom, remember, which is going to be 1 degree less than this. So I know it's going to represent a polynomial to the second power. So this is going to be 2x to the second power minus x to the first power, and then this would be plus 1. Okay, now, a while ago, I did the factoring, and I mean, it may factor, it may not. Let's just look at it and see. So I've got 2x squared, so that's going to be 2x times x, and then 1 times 1, okay? Now, this is not actually going to work, because if you have this last term being positive, that means your signs down here have to be the same. If you put both pluses, this would have to be a positive 3. If you put both minuses, then this would have to be a negative 3, okay? So actually, this is a situation in which it's not going to factor, okay? So this is where your quadratic formula is going to help you out. So you're going to have A is equal to 2, B is equal to negative 1, and C is equal to positive 1, okay? Okay, so let's write down your quadratic formula. We had dealt with the quadratic formula back in chapter 4. Okay, so I need to substitute in these 3 values here. So I would have negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times 1 divided by 2 times 2. Okay, so of course this is just going to end up giving me a positive 1. Okay, now underneath the radical, of course you can just use your calculator to help you out. This is actually just going to give you 1 minus 8. So that's going to give me a negative 7 over 4. Now, you will need to deal with the negative. There's not any simplifying you can do with the 7, but you do have the negative that you need to deal with. So that's going to be a negative 1 times 7. And if you remember, the square root of the negative 1 is going to give you I. The 7 then will just have to be left underneath your radical. So your roots or your zeros, again, you know, whichever section you're working with, the terminology they use. You've got the negative 1 that you found from the synthetic division. And then here's your other 2. Remember, if it's going to be imaginary, remember they have to happen in pairs anyway. Of course, you've got 2 answers because you've got the plus and you've got the minus. Okay? All right, so let's look at another one of third power. Okay, so if we do our P's and our Q's like what we've been doing. Okay, P is going to be negative 36. So all your factors would be plus minus 1, 2, 3, 4, 6, 9, 12, 18, and 36. Okay. Now, Q happens to just be an understood 1, so your only factors would just be plus minus 1, okay? So actually, your overall list here of P over Q is just going to be this same list of numbers because you're just going to put them all over 1. 1 over 1, 2 over 1, 3 over 1, 4 over 1. All right, so let me just rewrite these numbers. Of course, what you got to do is find something in this list that's going to cause your polynomial to equal 0, okay? So, you would probably start with, you know, positive 1. If you try positive 1, you plug it into your polynomial, you're actually going to get negative 30. So, we know that's not it. Then if you were to try negative 1, you're going to get negative 50. And then you just keep going down the list. If you try positive 2, you're going to get negative 26. Now, I'm not going to write them all down. But you just keep going. And actually, the first one you're going to come to is going to be positive 4. Okay? So, if you try positive 1, negative 1, positive 2, negative 2, positive 3, negative 3, positive 4 is going to be the one that you're going to need. So, we've got to do our synthetic division with the positive 4. Okay, so getting the numbers here to complete my synthetic division, I would have 1, negative 4, positive 9, and negative 36. Okay, bring your 1 straight down. So 4 times 1 is 4. Add, you get 0. 4 times 0 is 9. I'm sorry, 4 times 0 is 0. Add, you get 9. 4 times 9 is 36, and see, there's that remainder of 0 that you're looking for. Okay, so now, numbers across the bottom. So this was a third power. You remember our problem was a third power, so this is going to represent a second power. So I would have 1x to the second. Now, since I have a 0, that just means that I don't have this next term that has x to the first power. So it's going to skip that term, and the next one would just be your constant of positive 9, okay? So now, let's set this equal to 0. Now, this is not going to factor. You can use your quadratic formula like I did a while ago if you want to, but since I just have the squared term and the constant, I can use my square root property, which is, you know, a lot quicker. So if you'll subtract your 9, that'll give me x squared is equal to negative 9. Now you can take square root of both sides. So square root of x squared is x. And then you'll have plus or minus the square root of negative 9. So that's going to actually give me plus or minus 3i. Because if you remember, square root, 9's a perfect square. So square root of 9 is 3. And you remember the square root of the negative is what gives you the I. So see, we have that pair of being imaginary, okay? So your answer that you have here, your roots or your zeros, the positive 4 that you got from the synthetic division, and then you have the plus or minus 3i. So each of these examples that I've finished working have all been to the third power, and if you look back at each one of them, I've ended up with having 3 answers or 3 roots or 3 zeros.